So we're still looking at triple integrals in Cartesian coordinates, and there's this interesting question that we are looking at here. It so happens that the limits for all our variables x, y, and z from 1 to e, and the integrand is simply natural log of z by natural log of y by natural log of x. Okay, so this question is actually very simple. At first, when I saw it, it appeared to be a bit complicated, but it's actually not. It's very basic. It's very simple, provided you just follow things step by step and know some properties of some functions, the way you can simplify them. Okay, so this is very basic. It's pretending to be hard or complicated, but it's actually not. So let's expose it to say, yo, you are not complicated. You're not as complicated as you look. Okay, so now what the first thing that I can do here is to make an observation, and what I can see here is that I'm integrating with respect to z. So what this tells me is that this portion of my integrand, which is my natural log of y by natural log of x, is simply a constant. Okay, so I just have to focus my attention on this one here, and I can choose to get this, then bring it outside for convenience's sake. That's actually okay. It's up to you, or you can leave it inside. All you have to know is that it's a constant. That's what you have to keep in mind. So how do we then integrate natural log of z with respect to z? What we do here is we're going to use integration by parts. Okay, there might be another method that you're able to use. You can actually help us with that method if you have that base method that we can use instead of integration by parts. You can leave it down in the comment section. So what I'm going to do is that to remind ourselves, integration by parts is simply where we say um, u dv is equals to uv minus v du. So it's just a matter of choosing which one is going to be our u and which one is going to be our dv. Okay, so remember to say I'm just simply integrating with respect to z. So it's more like I just have something like this. You just see it on the bottom here. Like you have 1 here, you have e, then you have natural log of z dz. That's the only part that you'd want to focus on at this time. Okay, and yeah, that's what you'd want to focus on. And there's a way you can actually simplify this one, because looking at the nature of what we have here, maybe let me not go that route. Let me just explain what I plan to explain. Okay, so for this one, uh, our u our u is going to be equals to natural log of z itself. Okay, then our dv is going to be equals to dz, which is this one here. Okay, so it's more like this one is our u, this one is our dv. So our du is going to be equals to natural log of differentiate natural log of z. You're going to get 1 over z dz. Then when you integrate this one here, okay, integrating dv is equals to dz, you're going to get v is equals to z. Okay, so what this gives us is that you're going to say uv. Okay, you're going to get uh, uh, let me put it in brackets like that. U times v. What is our u? Our u is natural log of z. Our v is what? Is z. So that's just going to be like z uh, natural log of z. Then minus, I will do this. So that would be v. Our v is z, which is this one, multiplied by du. Du is equals to 1 over z dz. So you observe to say when you multiply this one by that z, the z is going to cancel out. So just remain with what? With dz. And remember, uh, your limits are from 1 to e. Okay, so integrating this one here, what do you end up with? This is still z natural log of z minus, just going to get a z there like that, 1 to 1 to e. Okay, so this is actually one of the interesting parts about this question, is because everything else is going to repeat itself. Even when I'm going to be integrating for x and y, it's still going to be the same thing. So here you just have to substitute. So the upper, let me do this, the upper limit is e. Okay, so I'm going to say you have your e here, natural log of e, okay, minus e like that, minus, then here you're going to have 1. I don't need to put it, like we put 1, then natural log of 1, natural log of 1 minus 1, like that. So observe to say this is going to give you a 0. How is this giving you a 0? This is very simple. It's because if you look at this portion here, this is a 1. Okay, so natural log of e is actually equals to 1. How is this possible? It's simply because natural log is simply log base e of e. In this case, this e is this one here. Then the natural log is the log base e. Okay, so now you're asking yourself to say, what number can I raise this base to, which is my e, to get this one? It's simply a 1. So it's simply, I'm just saying e to the power 1 is equals to what? Is equals to e. So this part is equals to 1, meaning 1 times this e, you get e minus e, that's a 0. Then natural log of 1, we know is a 0, because once again you are saying log base e of what? Of 1. So you're trying to say, what number can I raise e to for me to get a 1? It's simply a 0. It's simply a 0. You just say e to the 0, you get a 1. So here you get a 0. So this is a 0, that's a 0. Remember, you have a negative here, multiplied by that negative 1, you get positive 1. That's what we get. Okay, so we observe to say, when you integrate with respect to z, you're going to get a 1. So this now simplifies to what? To 1 to e, then another 1 to e, then this will be like natural log of y, then natural log of x, then you will now have dy dx. So let me challenge you on this one. The same way, if you observe, this is a similar thing that we have. Even this one, like, since I'm integrating with respect to y, I'll have to use integration by parts. So you observe to say, you just follow the same steps. If you integrate with respect to y, you're going to get a 1. I mean, after evaluation, after using those dimensions, you're going to get a 1. So you observe to say this one is just going to give you a 1, like that. You can actually pause this video. I was thinking of ending it right here so that you try it out, but you can pause it, try it out, and see if you're going to end up with a 1. So let me go ahead and continue with the inside integration. So here we can maybe get rid of this one. It gave us a 1, so we kind of like don't need it anymore. So that's what we have, and we have that. I can just erase that z there. So remember, I've said everything there that we have is equals to 1. So let me get the inside part. So the inside part again is like from 1 to e, you have natural log of y, okay, dy. So once again, using integration by parts, I'm going to let my u be equals to natural log of y, meaning my dv will be equals to dy. So du will be equals to 1 over y dy, then v will be equals to y. So we come back here and say, okay, I'll put this in brackets. So u times v, that's going to be y multiplied by natural log of y. Does this look familiar? Yes, it does. We got a similar thing with z, just that we had the z in place of y. Then we say minus v du. So once again, this is your du there. So if you multiply 1 over y dy multiplied by y, which is your v, that and that cancels. So that's why you just end up with the integral of dy there like that. Same limits from 1 to e. Okay, so this portion when you integrate, so this becomes like y natural log of y minus y from 1 to e. This even looks more familiar. It's the same thing that we worked on in talking about the z. So you observe to say even this part is going to give you a 1. So it's just more like all of them you're going to get a 1. So it's just like 1 by 1 by 1 to give you 1. So 1 is the answer. I'm hoping you're going to get that as you try it out on your own. Thank you very much for watching, and we'll catch you in another interesting video.